Good morning, good afternoon, or good evening, depending on where you are, and welcome to the Nautel webinar on groundbreaking. The GV series keeps getting better and better. And I'm delighted today to have Mr. Jeff Welton, the recipient of the SBE 2018 Educator of the Year Award. Congratulations, Jeff.
Well, thanks, Chuck. I've got to say it was a little bit of a surprise, but it was a real honor.
Well earned, well earned, and you're in good company. I have a lot of friends who have gotten that. I'm proud to have added you to that list of friends. So here's what we're going to talk about today. We're going to talk about the GV series, probably one of the most successful new product introductions this company's ever had back in 2014. The range now goes from 3.5 kilowatts to 88 kilowatts. We'll talk about what makes it special. We're going to talk a little bit about liquid cooling and the discussions that go round and round in the industry about that. We're going to take a little hands-on tour through the AUI, as we are wont to do, and we're going to take your questions and comments. You'll note that the application that you're running right now to watch this webinar, the GoToWebinar app, has a place where you can ask questions and type them in. And you can do that at any time during our webinar. And at the end of it, we will do our very, very best to answer all of your questions. If we can't get to them all, we'll send you emails after the webinar is over. Do remember that the completion of a Nautel webinar qualifies for 1/2 of an SBE recertification credit, identified under Category 1 of the recertification schedule for SBE certifications. So that's a very valuable thing as well. So Jeff, I think this is just phenomenal. Since 2014, Nautel has put 517 GV series transmitters into the field, totaling 9.3 megawatts. That's a pretty successful launch, wouldn't you say?
That's a fair amount of power. I mean, we've had a lot of good success with these transmitters, and we'll be able to talk about a lot of why that is over the next little while.
Mm-hmm. And this slide isn't even complete. It doesn't include the 60 and the 80 kilowatt, and I'm told that the very first 60 kilowatt recently went on the air, so that's pretty exciting. So it just keeps growing, it keeps getting better, and that's really the whole philosophy behind this webinar. So let's talk about what the GV series is. It includes asymmetrical sidebands, HD power boost, MER instrumentation. I'm not aware of any other transmitter on the market that includes instrumentation for checking the MER of HD radio. Are you, Jeff?
There is one other one. They're not quite as detailed as ours, and we can take a look at that when we get into the AUI demonstration and explain exactly why.
And part of that, the constellation view, the spectrum analyzer. Many people do not realize, and we'll show this, but the spectrum analyzer is actually two spectrum analyzers in one. It shows you, yes, the RF spectrum occupancy, but it also can be switched to show you the multiplex or the composite baseband spectrum. And between those two things, you can tell an awful lot about what's going on at your station.
Right, the baseband especially, and when we get to the AUI, I want to talk about that a little bit too.
Talk about HD reliable transport. How do you get the signal cleanly, reliably, robustly from the studio to the transmitter site in HD form? We're going to talk about things that have been done in the GV series to provide even more HD power and even more efficiency. And we'll demonstrate that before your very eyes. We're going to talk about the AUI web server with in-depth monitor and control, the RF and multiplex spectrum analyzer, email and SNMP. And I should add to that, not just email, but also SMSs. There's tricks you can do to send yourself SMSs out of your GV series transmitter, and as far as I know, that's still working. It depends a little bit on the telephone provider that you're sending to, but it does work. And then automatic logging, simple site control. This is a very, very cool feature. And the oscilloscope. Those were all added after those last two were added after the GV was introduced. So let's talk a little bit about the simple site control. One of the things that's very interesting about the GV series transmitters, and in fact all the AUI series transmitters, is that when the AUI was introduced, making it possible to control and monitor everything going on inside the transmitter over an IP link and a standard web browser, even so everybody used that, and very few people continued to use the GPIO control that it was built into the things, all the parallel inputs and parallel outputs and serial inputs and stuff. And we thought, well, how could we use those? And I think it was Mike Woods that came up with the concept, but we could actually turn that around backwards and allow people to monitor external equipment and then digitize that information, send it through the AUI platform, and allow people to monitor and control things based on what happens externally. So you've seen some situations in the field, Jeff, where people are using simple site control. Maybe you can explain a little bit of that.
Well, a couple that I've encountered. One of them was really cool because I had a site where they run their generator on a weekly test, and they have a specific generator mode set up for the transmitter. But during the test, when they're not doing a full load test, they didn't necessarily want the transmitter dropping power just because the generator status was active. So they just put a little AC relay, basically an AC detector, and used the Boolean expressions in the site controller. So if the AC was on and the generator was on, the transmitter stayed at full power. Beyond that, I've got a guy that uses the tower light. He measures the current through the tower lighting, converts that to a voltage, runs it through a comparator, and uses the higher low to trigger a tower light alarm.
So basically, if the current falls below what it would take for all the lights to be working perfectly, so even if one is off, then it falls below the comparator trip point, and it sends out an AUI message, email or SMS or whatever, or an alarm in the log that they may have a problem.
Right, and over and above that, as you and I had discussed previously, you could use a photo detector to determine day-night condition. Yep. And set your thresholds accordingly. So if you've got strobes, for example, where you're bright during the day and low during the night, then you can basically do time-of-day comparisons as well.
So this doesn't replace a whole big expensive site control system, but it's free and it's built into your transmitter already.
Exactly. It's belt and braces, so when, not if, because anything that current goes through, current will stop going through at some point. But when the site controller fails, you've still got belt and braces. You've still got something to let you know everything's okay, or not.
That's right. That's right. Okay, let's move on. The engineer's toolbox. So this was a term that Scott Marchand had for all of the tools that we put in the AUI, all the monitor meters, things that could show up in that quadrant of meters and graphs on the front panel of the AUI. So the spectrum analyzer, the EQ frequency response, impulse response, and the oscilloscope is one he was proud of because we added it after the fact. When people bought the GV series for the first year or two, they didn't know they were going to get an oscilloscope in there, but we came out with a software update and gave them an oscilloscope that they didn't have before. And one of the things that's cool about it is that it's a dual trace scope. Trace number one, the green, is the reflected or reverse path, and the blue is the forward path. And ideally, those should be one and the same. So because of the relative brightness of those traces, all you really see is the green. But if they're different, the nonlinearities, whether it's because you're over-deviating or something like that, will show up there. So that can be a very, very powerful tool if you take the time to understand that it's built right into the box and you can see it from any place.
Well, and another place that comes in handy, sometimes depending on the phase of a reflected signal, it may not show up as actual reflected power. But if you've got, for example, a coverage issue and you look at the scope and discover that the reflected and the forward don't match up, you may have a resistive reflection going on that is causing you some grief.
Understood. Okay, very good. Let's continue. So some of the things that are part of these transmitters in the GV series that cause the efficiency to be so high, and that's probably one of the most important features of the GV series, are the high efficiency LDMOS power amplifiers. We'll talk about those for a second, in a second. Platinum standard high reliability, high efficiency, that's 94% or more power supplies. The spectrum efficiency optimizer, we're going to talk about that a bunch because I think it's really cool. That dynamically adjust parameters to meet the spectrum mask while maximizing the efficiency. So let's talk about that spectrum efficiency optimizer. We will actually go to an AUI of an operating transmitter sitting in Halifax, Nova Scotia, and we will take a transmitter that's operating into a dummy load and flip that command on to turn on the optimizer. It turns out that really, really smart engineers like Mike Woods, for instance, of our engineering team, have known for a long time that you could sit down in front of a solid state HD involved transmitter, and by carefully adjusting it, you could optimize the efficiency, reduce the heat of the transmitter by understanding the relationships between many different factors. But the problem was that if something changed, the VSWR on your antenna changed, the temperature in your transmitter room changed dramatically, something changed, you'd have to go through that process again. And so what we did is we basically boxed up Mike and sent one out in every box. Not really. He'd probably complain about that. But basically we took the process that he was doing, automated it, and not just that. If he were going to do that to your station, he would ask you an important question, which is, how far below the mask do you want to be? Because there's a well-known trade-off between mask adherence or compliance and efficiency. So if you're willing to be very close to the mask, then you can have maximum efficiency. If you want to be further down with regard to spectral regrowth, then you're going to have better efficiency, and therefore it becomes a choice of okay, where do you want it to be? And so we give you that choice in the spectrum efficiency optimizer, and we'll show you how to enable that, how to make it happen, and we'll show you what the difference it really makes. It can reduce the power dissipation in your transmitter by 120 watts per FET, and increase your efficiency by more than 8% overall, while still absolutely maintaining mask compliance. And what's more important, if something were to change and you were to get a little closer to the mask limit, it can actually adjust and keep you to the level of compliance that you've chosen.
Well,
I think that's massive.
It's huge. And to geek it out for a little bit, I mean, everybody knows that the more linear an amplifier is, the better it'll do for HD as far as spectral regrowth, which is just effectively digital intermod. But yes, it does that at a cost of efficiency, because we all know that a square wave amplifier is a whole lot more efficient than a Class A amplifier.
Sure.
So the cool thing about this, the first NV series, you had the ability to bias the PAs, but it was a manual process that took up to half an hour. And a lot of that was off air time. And now we're doing it in software and dynamically biasing the PAs exactly based on the parameters we set for mask clearance and efficiency. So
Yep.
yeah, it's huge, and it's really awesome.
Well, the other thing is, in the NV series, we had a spectrum analyzer, and everybody thought that's really, really cool. And it was. But now what we've moved into is a spectrum analyzer that the transmitter itself is reading in real time. To use today's vernacular, this is artificial intelligence built into the transmitter. And the transmitter is self-aware. It knows how far below the spectral mask it is and takes appropriate actions based on it. It's hard to overestimate the coolness of that. So, my 2 bits worth. Benefits for minimizing power consumption, lowering operating the costs, and we can show that. Lowering the semiconductor device dissipation by 100 watts per device or more, which lowers the junction temperature and inevitably leads to higher MTBF numbers. It extends the fan life. Right now, the fans are only operating on an average of 63%. Reduces the external air conditioning costs, resulting in less BTU. Doubles up on savings. Simplifies the user setup and manual adjustments, which are now automated but configurable. And integrates with the AUI for non-compliance, i.e., if something goes dramatically wrong, you're going to get an email saying you're no longer meeting the spectral mask. And here's what we've done to mitigate that. So that's pretty cool. Like I said, it's like AI built into the transmitter.
Our own little mic.
Yep. All right. Things that make the GV series intelligent include Orben Inside, Omnia Direct, aka multiplex over AES. That's a really big one, and it's in other products now from Nautel too. Are all of our FM transmitters that our current manufacturer include MPX over AES? But I have to stress, if you haven't tried MPX over AES, if you haven't taken your fully digital audio processor, not just an Omnia, Orban, Wheatstone, all the major brands support MPX over AES. It's a digital MPX format that Nautel cooperated on creating over pasta in Madison, Wisconsin, with Frank Foti.
I was there last week.
You were there. I was envious, but it makes a huge difference. Not too many of the changes and revolutions that have occurred in broadcasting in the last few years make a difference you can just absolutely hear on air. This does. It gets rid of the extra A to D and D to A, gets rid of the noisy environment for the analog signal, makes your signal louder, and probably most impressively, it absolutely has perfect peak control. You can set your audio processing as hard as you want so that it hits 100% but not one iota over, and it hits 100% and not one iota over, and that's massive. So do try that feature if you haven't already. The internal scheduler, the IceCast Shoutcast input, we'll talk about that a little bit. USB playout system, like having a mini automation built into your transmitter for emergency use. RDS-PS scrolling for scrolling song title and artist display. You can feed it either with RS-232 or IP. And the RDS frequency table, alt frequency table, now 25 positions long, because people want to use this stuff. And some of these stations have a lot of stations associated with their network, so having the alternate frequency table have 25 positions is quite useful. So here's the RDS improvements. You wanted to talk about this, I think, Jeff, because it's not so hard to set up. It's pretty intuitive. But one of the things you found is that some of the systems, as I understand it, that some of the middleware and automation systems are spitting out the information to the transmitter far too often.
Well, and it's less an issue with the GV and more with the other transmitters that have ARM processors where the buffers can get overwhelmed. But it is also a challenge to the GV on occasion. And it does vary from one automation system to the next. Some, like the little community station that I co-engineer, we use a Rivendell system, and we can set it to send the RDS data once per cart change. So every time the actual presented content changes, it sends the RDS data for that content, and then it doesn't do it again until we change again.
Yeah.
Others have defaults much faster. One of the automation companies, the default is sending the data every half a second. And the problem becomes that sometimes it either overwhelms or overlaps itself, and you end up with garbled display on a car radio or whatever receiver. So backing that down is a really good idea. Now, on the one that defaults every half second, it can be set to as low as once per 20 seconds, which seems to work quite well. Every automation system has a control engine of some sort or a control manager where you can go in and set how often it sends the data. The other most common thing I see is folks forgetting that they do have to set the port number. They can't just point the automation to the transmitter IP address without telling it specifically what port to send the data to. And that is in the book. It's 7005 for anybody that doesn't know. But those are the things I see the most commonly.
That's great. Thank you for that. Okay. So what makes the GV series more reliable? Well, we're going to talk about the redundant power supply structure and the reliability of those power supplies. One of the things, Jeff, that you pointed out is that in the Nautel design department, there's a minimum overhead, not just of, transistors, but also like power PA FETs, but also other components where, if you've got a component rated for this many watts of dissipation, well, we derate that by 10%, and that's our headroom, and that's over maximum power. So for instance, if you buy a 40 kilowatt transmitter, that transmitter will produce 44 kilowatts all day long. But the fact is that it can actually produce another 10% beyond that it's software limited. We don't let you get at. It is kind of interesting that not all transmitters do that, Jeff. There are plenty of people out there that have transmitters that, if it's rated as a 1 kilowatt transmitter, it'll go 1 kilowatt with the wind at its back and heading downhill.
And that's not a new thing. I mean, if anybody's run into some of the older tube transmitters, and anybody listening is currently saying, "Oh, he's talking about pick a brand."
Yep.
There were a lot of them going even back into AM where you could do modulation or rated power, but not both. And on FM, you were not going to hit rated power unless everything was 100% perfect.
Right.
We've always chosen not to do that, so we do tend to, when we tell you a maximum rating, you're not running at redline. We've already built that in, and we're not going to let you get to it because we don't like to see anything do it. The best way to do it is count devices.
Yep.
I mean, anybody can tell you how many PAs they've got, not packaged power modules, but how many amplifier transistors are in the transmitter.
Right.
Count them. If you've got a 40 kilowatt transmitter that's got, trying to do math in my head real fast isn't going to work. But if you've got one that's got 64 amplifier pallets and another one that's got 60, well, the one that's 64 is going to be running a lot more comfortably at full power.
Sure. And all these manufacturers use very similar devices. There aren't that many devices designed for the FM broadcast band, and so we all share the same industry of solid state devices. So it's pretty easy to compare apples with apples.
Well, right. And I mean, ultimately, when you're all using devices with the same gain and all using power supplies with nominally the same power production capability, if you will, then it's not that hard to understand that the only way one can get a little cheaper than another one is to remove parts.
Just run a little bit closer to the edge.
Yep.
Yeah. Jeff, I know that this optional UPS interface doesn't sound very exciting, but you pretty much standardized on it, haven't you?
I won't write a quote that doesn't include it unless the customer specifically insists on pulling it out. Because we do have a lot of software and a lot of computerization, and that's true of any high-power transmitter anymore, then there is a start time whenever the power goes out or the lights flicker. So the UPS interface lets you connect an external computer-grade, low-power, it only needs to be 500 volt amp UPS, and it will hold the controller up during a short power interruption, so when the lights come on, the thing's ready to make power less than a quarter second later. Whereas without that, you'd have to wait for the start time. And this is another area where we learned from previous iterations. So now the UPS interface has an internal low volt supply of its own that's in parallel with the transmitter supplies, so that when, not if, the UPS itself goes sideways and stops working properly, you're not pulling the transmitter off air. It'll continue to run even with the UPS failure.
Yep. Yeah, very powerful. And so even though the transmitters that we have, the startup time isn't very long, it's nice to be going almost immediately back to high power.
Well, right. I mean, the startup time, if you do a comparison, one of our competitors runs about 10 seconds without anything holding the controller up. We're at about 6 seconds startup time.
Yep.
And even so, I watch, my wife is my metric for radio listening. Mm-hmm. And if a station goes silent, it's 3 seconds. One for her to realize, one for her second to get over to the button, and another one for her finger to push the button.
Wow.
So 3 seconds is my metric. If we can keep it below that, we're doing good.
And radio people know that, 5 seconds is significant period of time if you're holding your breath. But 5 seconds if your station is off the air is forever.
Yep. And the challenge is once somebody hits seek, it'll be a long time before they go back the other direction because they'll shut the car off, they get back in, it's still on the competitor.
That's right. That's right. Audio loss switching. So it's Nautel's experience that solid state studios these days are pretty darn reliable, and they're redundant in many cases. And solid state transmitters are quite reliable because of the way that they're built with so much redundancy built in. But STLs, getting the audio from the studio to the transmitter site, are not as reliable. And so one of the things that Nautel did, we don't make STLs, but one of the things that we did was to try to provide multiple audio sources that could automatically switch from one to the other to give you the the best opportunity to get back on the air and stay on the air, even if one of your STLs were to fail. And we'll go into that in a bit. We actually have a backup LCD user interface as standard in the GV series. We've got power supplies, but believe it or not, we'll go all the way down to 90 volts and still allow you to stay on the air. Now, anything below 175 volts, you're staying on the air at 2/3 power, or I'm sorry, 1/3 power. But still, that with the inverse square law, that's hardly detectable in many situations.
And one other thing that's worth talking about on that real quick is that a three-phase transmitter, the only difference between three-phase and single-phase is how the wires are connected inside.
Right.
And in a pinch, if you lost a pole pig, one of the transformers outside, you could reconfigure the transmitter to single phase.
Yep.
Keep it running that way as well. Like if you had an extensive flame out on a power transformer outside on the pole, that gives you a good option.
Well, and when you look at the kind of natural disasters that have hit the United States in the last few months, I'm sure when power comes back, it's not always optimum right at the beginning. So I'm sure getting stations on the air with that kind of functionality gets people on quicker, you bet, to be able to configure. 110-volt UPSs are now possible, which means your UPS that hooks up to Jeff's not-so-optional UPS interface can be a much less expensive. Finding 220-volt UPSs tends to be kind of more expensive. And audio loss switchback, and we'll get to that because that's really interesting. We've always had the ability to switch, but it always stuck there. And so the audio loss switchback was something that people have been asking for a while. Jeff, tell us about the backup user interface and the 110-volt UPS and why people are happy to have that.
Okay, well, on the original transmitters, and I mean, this has been true of every intelligent transmitter we've built, everything with the user interface, the AUI on the front panel. The touchscreen is really nice and really pretty, and it's also totally unnecessary. You can disconnect it, pull the front door right off the transmitter, and stay on the air and fully functional.
What?
The original versions had something like the remote interface board, but an internal controller with a couple of minimal LEDs and a bar graph for power. And it would allow you to have some very rudimentary control and some idea of your output power. But the internal controller goes way beyond that. You've got full access to everything by digging down through menu levels. And it's all well documented in the operations manual for the transmitter.
That's why I leave mouse.
We also moved the USB interface to the front, so if you're running USB audio and just for doing upgrades, anything like that, it's just a whole lot more accessible.
Sure. Okay. Very good. So let's talk about this audio switchback.
Say that 5 times fast.
I can't even say it once fast. So the concept was, for many years, we had the ability to switch audio inputs, but we didn't have a way to monitor the input that wasn't selected, or the previous input, and return when that returned to it. So let's assume that a station has got several different types of audio path between the studio and the transmitter site. So the number one would be primary digital, let's say in this particular case. If that should fail, we can set a level at which the level has to be a minimum level, and then we'll have a period of time with which that has to be the time has to be how long it's been silent. and then it'll switch to a secondary, which is programmable. So in this particular case, we could switch from primary digital, in the case of the audio being too low, to multiplex or composite. And if primary digital were to return, it'll automatically switch back. And then in addition, we can switch to other presets based on losses in audio. So suppose multiplex were to fail at that point. It could switch to a second preset in which primary digital was first, and because the audio is low, could switch to left-right mono. And if that didn't work, or if it came back primary digital, it would come back to primary digital. And again, we could do that whole thing again, and we could create this big loop of primary digital, in this case to secondary digital, which may be a stream input, from the shoutcast or icecast, web broadcast to the station, or it could actually be a playlist that you've created on the memory stick of WAV or MP3 type files that is put on it as an emergency last chance. And again, if the primary digital came back, it could automatically switch back. So, yeah, giving thought to these kinds of things when you're doing the installation is very valuable, because you're covered in the future should something go wrong. And all backed with the best support in the industry. I mean, the 4-year standard warranty, 24/7, 365 support. Phone home. Phone home is a wonderful feature. I'm going to show you when we go to the AUI Live. We'll show you how to enable that, make sure it's enabled and connected, because it can be such a valuable tool. And we've never discontinued support on any product in 49 years, and talking about Nautel continuous improvement. Here's an interesting chart because it shows the power levels, both in analog power and also in various different injection levels for HD. The power of all the models of GV from 3.5 up to 80 kilowatts. One thing that's important is Nautel always lists, even if we're indicating a digital station like this 220 dB hybrid analog number, we can do 10 kilowatts of analog power when there's HD at -20. So, stations are always, when they talk about their TPO, transmitter power output, that's always the analog number. That's what's on your license. The digital power is extra to that. Some of our competitors like to indicate the power of the combined analog plus digital, and that's not really all that valuable. But you can find those specs. I think you said, Jeff, they're on a brochure on our website.
On our site, yeah. If you go to the primary GV brochure, not for any specific model, and it gives you the chart including the FM plus HD combined powers for each injection level. Mm-hmm. And that is important if you're doing a comparison, because if we say 10 kilowatts, we mean 10 kilowatts of analog. If somebody else says 10.3, for example, and I'm looking at a GV15 at -10, right, then that 10.3 might be the combined power, and if it's the combined power, then they're significantly lower in analog power than we are.
Right.
This comes back to the power headroom conversation from earlier. It's when you're doing the due diligence, having two different sets of specs can be pretty confusing. So it's why we started doing the chart in the main brochure, to allow folks to have an apples to apples comparison.
You bet. Yeah. Very important, because when you buy a transmitter, you're buying the power that that you calculated the TPO of your station for, which is always based on analog power only. And even though the transmitter is actually, in your case, when you're talking about a GV10 or a GV15 at -10, that's actually 11 kilowatts going into the antenna, I believe, at -10. So that one extra kilowatt is the power at going into the digital side, and you're actually doing 10 kilowatts of analog.
Right. So if somebody else is speccing 10.3 as an example, then they're actually putting out about 9.4 kilowatts of analog and 940 watts of digital.
That's right.
It's a significant difference.
Yeah, you wouldn't want to be caught on the wrong side of that. So let's talk about air cooling and versus liquid cooling. There's been a lot of discussion recently. I know, Jeff, you had a discussion up at Madison recently on this, and there was a lot of discussion back and forth, and it was a good, healthy conversation.
We're friends. We're all friends. So we had a good time with it. I think we both made some points. It was kind of interesting because the other guy has worked with air-cooled transmitters before, and now is with a liquid-cooled company. And of course, and you can amplify on this, but we have some experience with liquid cooling.
Yes, we do. Interesting that you've got the photo of an NV20, because when the NV, which begat the GV eventually, when the NV was first developed, it was designed as a water-cooled or liquid-cooled transmitter. And it was pretty far down the design process. And it was only when we went out to our customer base and said, hey, this is what we want to do. What do you think of this? We got talked out of it. And we had to go back and redo the design of the NV series to air cooling. And there were a number of different reasons, but part of it was cost. Part of it was that it is significantly more expensive to purchase and install a liquid-cooled transmitter than it is an air-cooled.
Well, right. And I mean, typically it will vary, of course, depending on power level, because as you get to the higher power and the higher price, the cost of the external items, your air exchanger and your cooling pumps, those become less a factor. But you can figure anywhere between 5 and 15% more for a liquid cooled system. Mm-hmm. And there's a lot of plumbing that will add to installation costs. Yep. Now, if you're building a brand new site, that's a little less a concern, but on an existing site where you can almost always reuse the existing infrastructure, whether it's air handling or air conditioning, forced air or air conditioning, then that can make a big chunk of change that you don't necessarily factor into the purchase price.
Well, I think another thing that sometimes people are misled about is that there will be a comparison of efficiencies of transmitters, and they will compare a fully air-cooled transmitter, and that includes all of the energy consumed by the fans and blowers, with a transmitter that is liquid-cooled, but they don't include the pumps, and they don't include the fans that are on the external heat exchanger outside. And so it kind of makes the comparison a little less accurate.
Well, that's right. And I mean, you're not talking a huge number, 1.5 kVA or so, but it is cumulative. It does add up over time. And I mean, obviously on a bigger transmitter, again, it'll be less a factor because it is a pretty fixed amount, but it does have an impact that does need to be figured in. So when somebody's giving you an efficiency number for one transmitter that's noticeably higher than another one, where we're all using nominally the same devices, you've got to look to see where that extra couple of percent's gone, or where it's coming from that's not being figured in the calculation.
Exactly. And you pointed out that the when you have air cooling, it's a whole lot easier to do things, to change things, to clean things, to replace filters in an air-cooled transmitter than it is in liquid cool.
As a rule, I mean, the air filters are typically very easily accessible, plug and play. We use an odd size that is available online, but is a little harder to get. However, they're, typically you're looking $100 for a box of filters. And it's something that anybody can swap out in a heartbeat. Whereas in a liquid-cooled system, if you need to change the filter, which does need to be done after an initial run time, and then typically every couple or 5 years, whatever after that, you've got to be able to bypass that filter, take it out without spilling anything, swap in the new one, and it does take a little more time and a little more care. Absolutely. So it requires a lot more training and experience than, hey, go out to the transmitter, yank the filter off the back, and slam this new one on.
That's right. And from a redundancy reliability standpoint, I mean, there are so many fans that are a part of the GV design that one has, virtually no impact on the performance of the transmitter.
Well, the funny thing is, I've heard a lot of people say, well, with all those fans, you're going to spend as much on fans as you will on blowers or whatever for a liquid-cooled system. But I mean, I got a call from a guy with a MV10 that was sold in 2008, and they just replaced their first fan last week.
Yeah.
So, I
Yeah.
mean, one $20 fan over 10 years versus a $500 fan every 5 to 10 years, there's a somewhat noticeable difference there.
And there's another interesting thing. All of those fans, every one of them, is got a third wire on there. That's a tachometer, and it's actually reported the speed right back on the AUI.
Right. And the funny thing is, even our power supplies, which are a third-party sourced item, we tachometer monitor all of those as well. And going
Yep.
through the metering on the GV interface, you can see it all. One other thing, if you want to skip back real quick, there's one other thing I did want to mention.
Sure.
If you're in southern climates or southern states, more equatorial, the counterintuitive thing is that liquid-cooled transmitters can sometimes be susceptible to higher ambience because the hotter air will actually tend to heat the coolant rather than cooling the coolant. And you can get a little thermal cycle going on there until it gets to the point where it just won't run anymore. So it's not real common, but if you're in an area where the temperature can go up above 110 degrees Fahrenheit, then that's a significant concern.
You bet. You bet. And there are those parts of the world. We sell a lot of transmitters in tropical areas.
Phoenix, Las Vegas, Tucson.
Yep. So the cost of operation, we've talked about this quite a bit already, but the cost of operation, these transmitters are up to 15% more efficient than our previous NV series, 50% less temperature rise, approximately 10 degrees Celsius, auto variable fan speed, and up to 10 dB quieter than in NV. So these are all huge improvements, and it's tough when the thing you have to compare against is our last generation, more than 4 years ago.
Yeah.
We talk about continuous improvement. What does that mean? That means that we listen to our customers, we take their ideas and concepts and complaints and turn them into improvements. But it also means we work with our vendors to get better improvements. So the power supplies we've been talking about over a period of time have slowly improved, and we are now looking at MTBF numbers over 4.5 million hours. Do the math. That's pretty amazing. And the RF device that we're using now has been improved, and the reliability of that device, MTBF, measured over 3.5 million hours. These are incredible numbers. I know that the history of Nautel was started because there was a particular contract for a particular kind of transmitter. They didn't specify solid state. In fact, solid state transmitters back almost 50 years ago were unheard of. But the only way to get the MTBF numbers that they could get is to use a solid state amplifier. And so you can see that this has just continued to improve over a period of time, and that's why we get the legendary in reliability and robustness that comes in the Nautel design. One of the cool things about a software-based product is you can always go back and make improvements, and we've done that many times. More recently, we've improved network reconnectivity, so allowing the AUI to connect up better if there had been a temporary drop in internet connectivity. Improved exciter reset action when you're on UPS, more MER readings, improved fast VSWR shutback, improved IceCast robustness. All these things came from users telling us, you know what, it would be even cooler if you would do this. And Jeff, what happens is when you hear that kind of stuff from the field, you create what's called a JIRA case, don't you?
Yeah, basically any feedback we get from our customers, especially if it either requests a feature addition or has an improvement area, something where they say, you know, this isn't working the way I really need it to or the way I'd like it to, or it's not as reliable as I think it should be, then we go into an engineering database here in-house. We create what's called the JIRA case. The cool thing about a JIRA case is once it's created, it must be addressed. Our ISO procedures require it. Now, I'm not saying that we're going to do 100% everything we're asked to do. I haven't figured out a way to put the beer fridge into an NX50 yet. But once I create that JIRA case, engineering addresses it, and whether they agree to add it to a wait list, whether they agree to do an immediate correction, or whether they say this really isn't feasible and here's why, I'm going to get a response that I can come back to my customer and say, well, here's what engineering says. And I use that a lot when I'm communicating back and forth with engineering, because it's a whole lot easier to track than a conversation at the water cooler.
You bet. You bet. All right. So let's see. I think, yep. So this is where we go live, and we don't have as much time as I'd kind of hoped, but we've got some time. So I'm going to switch over and look at the AUI of a transmitter that's sitting downstairs from you right now, Jeff, in Halifax. Let's go ahead and turn. This is a 5 kilowatt GV5D that's operating on 98.1 megahertz in our test room, and you can see the power. This one's called Jeff FM. Wonder why, huh? We're running 4.5 kilowatts of analog power at minus 20. I think that is correct, minus 20. And what we're going to see here is you're going to see the spectrum analyzer start to come up, and you can see we're already passing the mask. Usually it takes a second before things stabilize and you start passing the mask. And our efficiency is this is DC to RF, is 61.3%. So the very first thing I'd like to do is I want to go to System Settings and the Spectrum Efficiency Optimizer and turn this on. So remember that 61.5%. And this is going to take quite a bit of time because there's a lot of analysis that's going on here. But you're going to see over a period of time, this is going to start creeping up. And as this, you can see we've got quite a lot of room below the spectrum mask. And so this is going to start creeping up. Now, in the meantime, while that's happening, remember that 61.5 we started off with. Jeff, I know you wanted to look at some things here under user settings that people can take a peek at.
Yeah, there were one or two things that, number one, click on the phone home link if you would. I mean, network settings and the other stuff is pretty intuitive for an IT person.
Yep.
But every transmitter we ship today for the higher power stuff, especially the GV series, has the phone home feature. When you tick on that, it what it does is fires a data burst back to our server. It's a one-way thing. It only sends data out, not in. And it lights a little light on a map of the office that puts a new blinky at 0.0 coordinates, and we'll go in, look up the coordinates for your station. Oh, yeah, don't put my email in there. But we'll look up the coordinates for the station, and somebody will drag it to the right location. At that point, if that transmitter ever fires a red light, an alarm of any kind, it will light a red flag on the screen in customer service, and the service guys can go in and actually see it. Now, over the years, we've done more and less with it. We're starting to focus on improving its performance a lot more. The funny thing is, and this comes back to that, how many GB transmitters we've sold. Well, the NVs before that, the VSs, the NXs, they all have phone home.
Yep.
And we did not expect it to be adopted nearly as fast as it's been adopted. So we've totally blown up 2 servers in the process of trying to keep up with our customers turning this feature on. You know, we've gone way beyond Moore's law. But the cool thing about that is now that the service guys can go in, they can see the history of the transmitter. Beyond that, you see the little checkbox for remote service. Don't check it.
Right. Nope.
But that, if you've noticed when you go to a hotel and you turn on your laptop, if you've got Skype as part of your startup, before you even hooked up to the hotel Wi-Fi, your Skype's enabled and running, because it will punch through virtually any firewall in the world.
Right.
And that's what the remote service does. It drags a connection back to our servers that allows us in, you know, even if you don't know how to get you through your firewall.
So we can look over your shoulder and look at the AUI and understand what's ailing you.
Right. Or we can go into the factory settings and take a look and make sure that everything's as it should be.
Right.
But that's why it's got the note, only do it basically when you got the service guys on the phone, because it it does kind of negate a lot of the protections of a firewall. So from a network security standpoint, it definitely should never be left on.
Sure. Jeff, I know you wanted to look at turn-on behavior as well.
Right, and this is something that I don't know if it's unique to us. I know one of our big competitors does not do this. But if you're in a situation where you go to generator, you've got the ability both to delay how long the transmitter turns on. Your controller, your generator controller may take care of that for you, in which case you could leave it at 0. But the other really cool thing is we can slow down the ramp-up speed, how fast the transmitter ramps up to full power. So we can we can lengthen the time it takes for the load to be applied to the generator. Yep. So rather than hitting a generator with full tilt load instantaneously and having it lag down and cycle, we can slow it down. Like if I set it for 10%, it'd take about a full minute for the thing to get up to full power.
I know you wanted to mention user thresholds. That's something that a lot of people aren't aware of.
Well, you were talking with the audio switching circuitry and the revert to normal and all that. You've got the ability to set for both main and SCA audios exactly where those trip levels are. Same thing, the other tab up there, the low forward power, you can tell it at what point the power is low enough that the transmitter should send you an alarm. So for example, in the US, if you wanted it to alert you every time you're below 90%, which is the minimum level by FCC decree, then you can have the transmitter send you an email whenever forward power drops below 90% of assigned.
Yep.
So that's useful.
You bet. I do want to have some time for customers or for people to ask questions, but just remember, we said 61.5%, wasn't it?
Yep.
And now it's 75.7% efficiency. So the spectrum efficiency optimizer has done its job, and we still have the requested amount of spectral mask clearance here.
Yeah, actually closer to 6 dB. We're 20 dB per division on that scale.
That's right. That's right. Very amazing, I think. This is one of my favorite features ever, is this DC to RF efficiency through the spectral efficiency optimizer. Let's go ahead, Jeff, if you don't mind, let's go ahead and start answering some of the questions that people have got. Before I do that, anything else you wanted to show real quick? Or do you think we've got it pretty much shown?
I think we covered the bulk of it. One other thing that is really cool from a troubleshooting point of view, talking about the toolbox,
right,
is the Lissajous plot.
Yep.
Especially if you're not running composite. If you are running composite, because that's a pre-modulated signal, it'll just look like a circle.
Right.
But if you're running, and I had a guy call me last night, and he goes, my Lissajous plot's changed. It's just a horizontal line. And it's like, well, you got left channel audio. Bang, problem solved.
That's right. Exactly right. It's amazing how you can be hundreds of miles from the transmitter, looking at things on your laptop, for instance, and you can diagnose exactly what's happening from that distance without listening to it. You can just see exactly what's going on with that Lissajous. That's right.
Right.
Okay, so let's go ahead and switch back here to this and come down another slide, and we will go to your questions. Now, if you haven't asked a question so far, this is your chance, but we only have, it looks like, a few. So let me go ahead and open those up. All right. Let me get this. There's more than I thought. Okay. Matthew asks, any chance the AUI for the VS series might also incorporate simple site control?
The VS with the ARM processors is a little more limited. There has been some discussion about it. I'm not sure where it is right now. The funny thing is, because I was playing with the VS last week, and I don't remember, well, I wasn't in the remote control interface at all, so I'm not sure what the current software revision has got for features.
Matthew, we'll check that and email you. Is the efficiency optimizer strictly for HD setups?
Yes.
Yes.
Yes. Well, primarily because we dynamically bias the transmitters now as opposed to manually. When you're running analog only, it's automatically set to the most nonlinear mode.
Sure.
So it's biased for a Class CE operation, and it's running 72% overall or 80+% DC as it is.
Yep. Can we use the Arctic Palm software as an interface between the automation system and the transmitter?
Absolutely. I'm glad you brought that up. Who was that?
Marco.
Oh, hey, Marco. Arctic Palm Center Stage works wonderfully. I did a article and a presentation with Alex Hartman about that not too long ago, and I think you can find it on our website. If it wasn't one of my tips and tricks articles, it should be one of the archived webinars.
Perfect.
But certainly we've used that. Stu Buck's been a great friend at helping us get this set up.
You betcha. Is the auto audio switchback, see I said it, available for other series of transmitters like NX or NV or VS?
VS and NV, I want to say it was added in the most recent or one of the recent major software updates. I don't know about NX.
Okay. Can you provide a link for filter purchase? Dan will send you that.
That, what I will do, if anybody's interested, send me an email, jwelton@nautel.com, and let me know where you are, because, of course, it'll vary depending. But I want to say Filters Are Us is the one that I've been using mostly.
Right. Okay. 3.5 million hours is about 400 years. How is that number determined? Are you saying the RF devices should be able to run for 400 years? The power supply's MBDF is really over 500 years, ? So yeah, that's actually the way you calculate MTBF is you look at the number of devices in the field over the period of time that those devices have been in the field, and then you look at the number of reported failures and you do the math. Now, it is possible, in fact, it's very likely, that your MTBF as viewed on an entire transmitter is much less than that. And the reason is because you got a whole lot more than just one of those devices in your transmitter. So if you've got a 40 kilowatt transmitter, you got to divide by the number of either power supplies or PA transistors that are in that transmitter, and you'll find that, it's possible you could have a power supply failure in a year or a few years, but that's still pretty amazing.
Well, and to break it down just a little bit, just because I happen to have the original data in front of me, to give you an example, if you look at the latest revision of the supply, which is our part number UG92B, there's over 7,600 in the field with a cumulative runtime of 6.7 times 10 to the 7th run hours, and a total reported failure rate in the year that I'm looking at of 15 failures.
And that includes things like lightning and all that kind of stuff too.
Right.
Yep. All right, got a question from David, who asks, is the AUI running an HTML5? Not yet. But we're working on it. Watch this.
And for what it's worth, Chrome in the version 69 update about 2 weeks ago did remove the ephemeral connection so that you could just select use flash on this website. It was always enabled. Now you have to enable it every time.
Yep.
But there is a workaround for that, and if anybody's interested in it, I've got a copy of it that I can email out.
Sounds like good stuff to go in your hints and kinks in the future.
It will probably be featured. There's one coming out in about 2-3 weeks.
Yep. Kurt says, I've got a really stupid question. My chief engineer and I are debating the proper pronunciation of XGen. I haven't heard it in any fashion than that. Have you?
I think you just pronounced it the way I pronounce it.
Yeah, okay. Eric says, can you briefly cover interpreting the MER data?
Yeah. Chuck, can you get us back to the user interface?
Yeah, I don't know if I can. Let me see. I'll do my best. Let's see here. All right. And then we'll click and maximize that. There you are. All
right. So basically, anybody who's done TV knows that the short answer is that the better your MER, the better your coverage.
Mm-hmm.
So what we're looking at here is effectively digital coverage.
Right.
Now, the advantages we've got is that you can look at any part of the spectrum, and if you see your MER going higher, like in this case, it's pretty consistent all the way across because we're in a dump mode. But if we were in a channel combiner or a narrowband antenna and you started to see it go up in various places, you could potentially see areas where you could improve your load to improve the coverage.
And conversely, if you happen to notice that the hang on a second. If you happen to notice that the MER is reducing as you get closer to the carrier, then in some cases it's due to overmodulation in the analog.
Right. And I mean, I did a paper at NAB talking about the various things in HD that have been issues. Some have been resolved. Some are just setup issues. Mm-hmm. And that was one of the things we talked about. A lot of the interference complaints are either overmodulating or antenna layout.
Right, right. Javad asks, are all the new features part of the version 4.4.1.8?
I think on the GV we're up to 4.5 or 4.6 now, aren't we?
I think so.
I mean,
in any case, when you log in via your NUG account, you can easily find out exactly what the current upgrades are.
Right. I mean, 4.5 was released in January of this year.
Right.
So that one is good because it had some bug fixes in it. My field service guy says that I've got to beat this drum, but years ago we used to send out plastic bags with instructions and resistors and capacitors that said cut this track here and install this jumper here and put this part here and replace this part with that part.
Right.
Now we send out a software release.
That's right.
The funny thing is that my running joke was it was nothing for me to walk into a site as a field service guy and see a little cardboard box with 20 baggies in it that we'd shipped over the previous 10 or 15 years. Yeah. Well, now I walk into a site and see a software update that's 5 generations old.
Right, right.
So by all means, you should do those. It's not just stuff we do to add features. Sometimes we actually change things for reliability as well.
Big double thumbs up for making sure you're up to date with your software upgrades. I know we're up to 4.5 or 4.6. Check on support.nautel.com. You know, Jeff, we have many more questions, and they're coming in faster than we're able to answer them online here. So after the webinar, Jeff and I are going to sit down at our keyboards and answer questions and send them out via emails. I think we've gone way past our expended time, and I know that's because there's been so much interest and so much cool stuff to talk about. Look forward to doing it again. Jeff, I always enjoy chatting with you. There's always a pleasure, and I learn stuff too.
It's a whole lot of fun, and I can say that goes both ways.
Thank you, my friend. So for Jeff Welton, and I'm going to put up one last slide here so that you can all take a screenshot of this. But for Jeff Welton, I'm Chuck Kelly, and thank you for being a part of this webinar. And do feel comfortable in writing either Jeff or myself with any questions you may have. Absolutely. Thanks very much for being with us all, everybody. Bye-bye for now.
Bye now.